Hi Heather, I thought I'd make you a little video to work a couple problems for you from 13.6. I wish you would look at the recording of last week's chat because I went over problems just like these. So let's take a look at a couple problems here. The first one I picked was problem 10, and it said find the area between two z-scores. Right? So it's between negative 0.69 and negative 2.21. And the table links are there. I'm going to go over to my math lab in a minute. So both of these z-scores are negative, and the first page of the normal table concludes all the negative z-scores, so we're going to go there. So the first one I'm going to look up is negative 0.69. So I've got that problem over here, and I said they're both on this part of the table, so negative 0.69. I'm going to scroll down, and the left-hand column gives me the first part, the whole number, and the first decimal, and I want 0.6 negative, so I'm going to go down to 0.6. And then I want 9, which is the last column, so it's 0.2451. So negative 0.6, and if you notice this column is the 0.09, so that's the negative 0.69. The area to the left is 2451, which is what I put down here. And then negative 2.21, let's go back to our table. Negative 2.21, negative 2.21, okay? So 0.0136, and when I'm doing the area between, I subtract. So I took 2451 and I subtracted 0.0136, and I got an answer of 0.2315, which I went ahead and I entered into this problem, and that was the correct answer, 2315. Okay, I also picked problem number 8 to do for you. Problem number 8 is just finding the area to the right of a particular z-score. Now the tables show the area to the left. Go and click on the table, and this is a positive one, so we're going to use this one here, and it's always to the left, right? And in this case we're doing 0.01, so it's 5040 is the area to the left, but we want the area to the right. So to get to the area to the right, the whole area under the curve is 1, so we're going to subtract the area to the left from 1, and that will give us the area to the right, 0.496. Right? And then the last problem I picked, I'm not sure if you know how to do the z-scores or not, but I picked one of the ones where you're actually doing a z-score, and that was this problem here, number 17. Assume the math scores on the SAT are normally distributed with a mean of 500 and a standard deviation of 100. What percent of students who took the test have a math score below 520? All right, so we need the z-score for 520. So I took 520 and I subtracted the mean of 500 and divided by the standard deviation of 100. So I get 20 over 100, or 0.2, and we want the students who scored below, so we want the area to the left. And again, we're going to use page 2 of the table because that's where the positive z-scores are. And I want 0.20, which is right here, 5793, and to get to a percent I multiply by 100, so we expect 57.93% of the students to score below 520, which makes sense because this 520 is above the mean, and we know the mean sits right in the middle of the distribution. 50% will be below, 50% above. So this is a little bit above, so we're going to have a little bit more than 50% scoring below that 520. So hopefully this will help you, and again, I really would urge you to take a look at both the notes for section 13.6 and also the recording of last week's chat, because I went over questions just like these.